Hello, I am Jyoti Murugan, Prayasi under PhD step IDpro scheme. I have received a fund for developing my project electronic process identification system, which is developed for textile industry, especially for spinning mills. A spinning mill contains three different stages, for example spinning preparatory, spinning and winding. My invention belongs to spinning preparatory department. In that department there are 6 stages. A fiber has to cross the 6 stages to enter into the next department. So each and every stage the materials are transferred using the containers like this. In the existing technology they use different colors of containers to differentiate each and every process. Or alternatively they use different color bands to differentiate the product. For if a single can mixes with other process, or if the band is missed, then the can will be mixed with the other process, then 1500 kilos to 2000 kilos will be a loss. So to avoid that, we have introduced electronic tag based process identification system. For that we have developed 2 different prototypes. One is for the new machines and other one is for the existing machines. Apart from that, we have developed an IoT system to monitor the process 24/7. We have also developed a handheld device to identify each and every cans by manually. Let me explain the first product now. This is prototype model 1 of electronic process identification system. This prototype consists 2 units. One is encoder apparatus and other one is delivery portion of a spinning preparatory machine. Normally the delivery area consists a coiler plate where the cans are kept and it starts rotates while running. This is the replica of main control unit of a spinning preparatory machine. So here you can find the process code, operator code, machine number, date, time and other details that can be entered here based on our requirement. And the encoded the data shall be encoded into the electronic tag. The back portion consists encoder apparatus. It's mounted on a linear motor. It moves to and fro based on the sensors. There are 2 sensors. One is a distance measuring sensor and the other one is depth measuring sensor. And we have an encoder unit. Let me explain. For example, this is a tag. So let us assume the can is approaching. See, it's sensed, it starts moving towards, and the depth sensor, the coiler plate starts rotating, and when the tag is approached, then it's encoded and the encoder unit moves backwards. So this is the normal process. When the data is encoded through IoT, the data will be transferred to the IoT system. This is the functionality of prototype model 1. This is prototype model 2. This can be mounted in any of the existing spinning preparatory machines. This model consists 2 portions. One is the encoding apparatus and the second one is the driving arrangement. This driving arrangement consists a drive motor and a set of guide pulleys which is used to rotate the containers. In the earlier model, there is a coiler plate, but in this, even the cans are stand still. This the guide pulleys can rotate the containers. This is the encoder apparatus. The front portion consists a display unit where you can find the details as we mentioned in the prototype model 1. That's a process code, operator code, machine number, date and time. The back portion of the encoding apparatus consists of an encoding device and 2 sensors. One is the distance measuring sensor and one is the depth sensor. You can see the encoder device here, the encoder unit. And when, for example, when a can approaches, it starts rotating, it moves forward. See? The guide pulley can rotate, and when the tag is approached, it's encoded and it moves back. This is the working method of the prototype model 2. Let me explain how it works with the containers. For example, this is the container, the can. Just I am moving it towards here. So you can see a transponder there. So the distance sensor measure and can starts rotating, and now the transponder is moved there, so encoded, and the encoder device moved backward. So this is how the prototype model 2 functions. This is the decoding apparatus which can be mounted in the creel portion of any spinning preparatory machine. Let me explain about the components. This is the display unit and signal lamps, and this portion consists of alarm, and this area consists of tag sensor. So what you see here is the data, so we can enter the desired data here. For example, I have set the passcode 1, and now the can is approaching the decoding apparatus. So when it reaches here, so it's a right can, it gives a green light and the details are displayed in the display unit. Let us see what happens when the wrong can enters. Now we can change this data into other process code. So now it is 2. Now the can with the wrong transponder is entered. So there is a red can and gives a different beep, and it displays the exact data encoded in the transponder. So this is how the entire system works when in the area of creel portion of the machines. Whenever the wrong cans approaches, it gives red signal, and the intimation should be forwarded to the floor manager through the IoT system. When the right can is approached, then the data is included in the total database, and the exact details will be displayed in the user interface devices. Yeah. What you can see here is a handheld device. So there is a display and a sensor here, a tag sensor. So normally this display comes here like this, and when we scan the tag, it scans and it can display the details encoded in the electronic tag. So a normal person, an operator, the floor worker can use this handheld device, and he can easily identify the containers without any confusion. This is the electronic process identification systems display area through IoT communication system. Through wireless communication from each and every machine, the data will be transferred to the central server, maybe through cloud storage, and the display unit displays the data 24/7. Each and every minute the data will be updated. This is the example of spinning preparatory department. There are carding machines, lap forming machines, combing machines, draw frames and speed frames. The process details can be monitored in two different ways. One is machine wise and other one is process wise. In machine wise, for example, if you click the carding machines, the machine numbers and the process code, when the process is started, when the particular process is ended, how many cans are processed in the particular machine, and what will be the total production. So each and every machine's data will be updated immediately, so that the floor manager and the operator can be monitored, and the process flow can also be monitored. The another method is process wise. For example, process 1, in each and every department, when the process is started, when the process is ended, and total cans processed in the particular process, and total production achieved in a particular process. So these data will be automatically updated, and it can be monitored at any time from anywhere in the world. This is the best advantage using an IoT for process monitoring system.